crazy as this sounds, my good friends, I have just been, for many, many years, I had this as a perch for Caesar, my pet goose. And I always thought it was a petrified tree. But I just did one on hair segments the other day and how they fracture in chunks, and I just never even given another thought. But then I just started looking at it, and I believe this is where the erector pili muscle attached to this, and I believe this is not a tree. And as I looked at it, and the transition metals and the colors, I think Caesar's been sitting on a hair. All this time, Caesar, I didn't know. Caesar Augustus. You see his feathers? So anyway, I'm sorry, Caesar, buddy. You're going to just have to hang on to that hair. That's all I can say, man. That's all we got for you. Now, I'm going to just go ahead and explain, or I already have explained, the situation with hair and how it goes in chunks and it has very little transition metals. Almost none. Thousands of times less than in body tissue. We're going to get into it. Okay, my friends, as hard as it is to believe, I may have been wrong. At this moment, I'm not 100% sure of too many things. I am 100% sure of this. This is Crowley Lake, and these are gigantic hairs. The black is the vein blood, the red is the artery blood. This is kaolin clay, or however you want to pronounce it. And these were the facial hairs of Scorbzilla. That I'm 100% certain of. And that's Crowley Lake. And this is what it looks like above. They look like trees, but there are all these little blocky things falling off of them. They're hair stubble, literally hair stubble. Now, I have been under the assumption, and I think wrongly, that anytime you see these blocks, just automatically it's a hair. Well, that's what I thought. But I do continue to search these things. This is, what would this be? In my mind, this is blood and so forth. These are all the colors of blood, the black, the red, the yellow. And this looked to me like it was, I mean, you could take it as a tree ring, but they don't normally have those colors, I don't think. You have to have a lot of transition metals to have these colors. And I don't think tree fluids have this kind of metals, but I could be wrong. This is what I'm saying. This is a little tricky. I saw this, and these are all little blocks. Like nobody came out here and cut this in the middle of nowhere, and all of these little blocks ran down. And this is blood. I'm 100% sure of that. I really am. This is the way blood balls up, and it's just everywhere. This is, to me, that almost certainly is hairs, but I can't be 100% positive. This, however, is something that freaks me out a little bit, because they do have, they're made in blocks. Basically, trees are made also in blocks, and they have these sieve plates in between to transfer fluids, I guess, to sort of pile them up here and then pile them up there and something like that. And I was not fully aware of that. And when I saw something like this, I said, "Oh, look, there's a break. This is a hair." And I still think it is, but I can't be positive. I cannot be positive. But what threw me for a loop here is when you cut a tree and then you let it dry out, it doesn't dry out into blocks. You put I just had my deck redone, and the boards are very long. And they're just one piece. It's not chunk, and they fall apart after a while. So this is what's got me confused. Why don't we see blocks of wood everywhere if trees are constructed in this manner here. Block, block, block. This is where I'm confused. This is what's got me confused, my friends. Now this is what a hair looks like on a cross section. You've got all kinds of little things going on. But on the outside, you're going to get a really scruffy looking stuff on the very outside. And then you're into the flesh, dermis. So this is a cross section of the epidermis, and you see all these little flaky looking things, and that's what you find near these hairs. But once you get to the inside of them, they're pretty solid. Like when you look at this here, you see how all this outside stuff is just flaky, falling off stuff. That's not really, I don't think, too much like bark. At this point, I'm a little bit on the confused side. I would have to do some chemical analysis on this, but I really still think this is a hair. So I just wanted to speak about what I said the other day. Was I'm certain I know this for a fact. Well, sometimes you get it right, sometimes you don't. But if you can't think and contemplate whether you did get it right or not, then you're not really much of a scientist. And I consider myself a pretty good scientist. If I was wrong, I'm wrong. This is tree rings. Now, and a lot of trees, they're not 100% exactly the same, all trees. And they don't grow exactly the same under different conditions, drought and so forth. You see all these tree rings? Now, I had one here that was very similar. Well, look at this. I don't know if those are tree rings or not. I really don't. At this point, I don't know. But if they are, they're pretty good sized tree rings. Everything was just absolutely gigantic. And the trees, I'm sure, were the same thing. They were just absolutely gigantic. But they didn't do well in the great boiling hot flood. They basically dissolved. There's a red bed in during this flood. All the creatures boiled. Everything boiled. The red, fleshy, bloody stuff came right out from the creatures' bodies during the boiling very quickly and created a red bed. It sort of settled into a red bed. Just mud, literally fleshy mud. The redder, the fleshier. And then all of the plant life and so forth piled up on top of that, more or less, because it's a red bed, gray and green clays, which is this stuff, all dissolved, and then a black cap, which was all the fallout from the volcanism and the burning and all that stuff. And those are the three layers that created all the mud fossils, and they call it the Triassic. And they claim it was millions and millions of years ago, 540 million years ago or something like that. It's not. Everything is right on the surface of the Earth. It's not. It wasn't 500 million years ago. So anyway, let's just get past that. Talking about, is that a tree? I don't know. At this point, I'm starting to wonder. I had said, well, now I know for a fact that's a hair. Well, maybe yes, maybe no. I do see the colors I expect to see in blood. These are colors of blood, transition metals. And your body and the blood in your body is just saturated with transition metals. Basically all it is. I still have to go along with my original thinking that this is hairs. You see that color? You see this color? Even though that looks like a tree, this could be, and it could have just been right next to where there was a ton of blood. That I don't know, but I suspect it is a hair. And as we saw, here's what the hairs look like. Cross section of a hair. Now, very similar to a tree. I don't disagree with that. Only these are little shards. They're not like a tree growth ring. these are the growth rings, and they have like a fluffy layer between the rings. And I don't think I see that. Well, I guess that could be the fluffy layer. I don't know. This could be a tree. That's the key. I don't know. I'm not sure. I'm still not sure. However, when I see colors like this, of that I am almost 100% certain that is a biology of blood and the colors of blood. And I can show you the evidence why I say this. Colors require these transition metals. That's what makes the colors. And all this is because of polarities in the blood. Primarily, it's in both vein and artery blood, but you get the most vibrant colors from the red, I believe. That's my take at this moment. Things change. And these here, this is the most vibrant looking colors I've ever seen, basically. I mean, they're just, and I can see all the little red blood balls everywhere. This is, to me, this is just a pile of hairs, and there's a whole ton of them in the valley down below. And it's just basically stubble, and they break off in segments. There is no question about that. Now, there also is the trees do that. But the trees don't have the transition metals. And when I say transition metals, basically all of these different metals, iron, all these these are all different metals that are in with the silicon dioxide, and then calcium oxide, sodium oxide, and the metals, basically. Now, let's take a look at what actually makes up blood and what makes up fluids in plants. Totally different. That's where I feel confident saying that the very brilliant colored ones are from biology of creatures. Something like this, I don't see a whole lot of color here. That I could go with tree. I don't see a whole lot of color. Normally, when you see biology, you're going to see some color with it. Now, I think this could well be a tree. At first, I said, there's no hair. There are just hairs everywhere. Nothing but hair. Well, maybe, but I don't think so. I think that could be a tree. Now, there are gigantic tree-looking things that come up like this, but they're not trees. They're tendons from giant creatures. And the creatures that were here were just staggeringly large. Look at this guy saying, what the heck is this? Those are hairs from Scorpzilla. And they break off in chunks. They're laying all over the place down here. And I mean, the whole thing is, this is Crowley Lake in California. And it is the beard of Scorpzilla. If you've been paying attention, that's what it is. And here's what they are. They come up and they break off. Similar to this. Your skin is just nothing more than clay. I'm telling you, that's exactly what it is. It's clay. And it flakes off like little pieces of clay all the time, all the time, all the time. And these little, look at that. It's just nothing but clay. And then these are the hairs coming up through. The details are very interesting. And here's how big they were. This guy's standing here with that's a sweat gland next to a hair with the vein and running under, or artery running underneath at the basement layer of the skin. In humans, there's sweat glands next to the hair. In animals, in these giant creatures, they didn't have sweat glands. They did not have sweat glands. There's no sweat glands in anywhere here. I looked at a lot of stuff about that area, and there is no sweat glands anywhere. Normally, just about every hair or two, there's going to be a sweat gland. But, there's a lot of animals don't have sweat glands. Mammals have sweat glands. I think all mammals do, certainly humans. Okay, I'm going to show you, or have shown you, how important it is for these transition colors, metals, to make colors. Now, here's what it says about transition metals. There's a big difference between plants and animals when it comes to the amount of transition metals that are in the fluids. That's why I feel comfortable that most of the stuff I'm going to show or have shown is actually, when you see a lot of colors, it's from a creature. Now, here's the difference. Transition metals in human blood. Metal concentration, iron from 1,000 to 1,500. All right, iron, and then the other ones are pretty high too. But in transition metals in plant fluids, iron is less than 0.01. Almost no iron. 0.01 compared to 1,000 and 15, up to between 1,000 and 1,500. And the red blood cells, basically, they're loaded with iron to transfer oxygen using the different states of oxygenation. It's an elegant system, and it works very, very well. Now, iron in the chloroplast, mostly it's in the roots and in the leaves, which go away, so they're not in the stems anyway. And all they have is 0.01. So you're not going to see any really bright red little spots. To my way of thinking, you just don't see that in trees. Well, you might see it in some trees, I can't say. And then zinc is way down, 0.01. Copper is 0.001. Up here, copper is 1. Zinc is 1. But down here, zinc is 0.01. Copper is 0.001. All right, so human blood contains significantly more transition metals, especially iron and copper, than typical plant fluids. All transition metals are in the blood. They consider them trace metals. When compared to iron, yes, iron is saturated with iron. It's absolutely saturated. All the red stuff comes out of you as iron. Okay, look carefully. This is where the attachment was. You can see some black blood and some red blood, and this was the center attachment. These are the tendon fibers. They're a little tough to see. Let me see if I can home in a little better. Well, let me put my finger in there to show you how big this is. This is like a little, it's like a bucket. I can feel my finger is in there, and it would be pulling straight out this way. These are the little straps. I'm going to put a little water on them. Sometimes that brings them out a little better. This is nothing more than a round anchor. That's where the muscle that attached is called the erector pili muscle attached, and these are some of the fibers. Now, let me come down a little closer. But I can put my finger in there. It just feels like a little round hole. I'm putting it in here, wiping it around and around. You see? You see that? That was an anchor, and it just pulled right out that particular muscle. And that is the erector pili muscle. Now, let's come down and see if we can see some of these straps a little better. Well, I don't think too much. Oh, you can see them pretty good. They come down and see, you see them? You see them coming out of there? See? Those would have gone up to to the skin, literally, to pull the hair to make it go erect, and then that's your hair standing on end, they call it. You can see that those are all connective tissue fibers. You see this? I basically missed all this. That's red transitioning. You got your black vein blood there. This is the outer edge. You see that? That's not a tree. You see that? Those aren't tree rings. That's from blood and the layers of tissue. Not a tree, my friends. I could see where somebody might think that. And some of those little lines, no, these are lines that are from the tissue itself. At first I thought maybe they were cut, lines showing the cut. But we know that there is nothing but layer after layer after layer. It's similar to a tree rings, yes, but this is not a tree. This, my friends, is a hair. That's my take on it. I mean, it could be verified one way or the other, but I'm saying this is blood. All right, this is the other side, and you can see what you see there. That's not a tree. These are all the little layering of the hair. It's kind of interesting. You see the different materials? I'm sure that's blood. This is not a tree. You see, the only thing I can say is it has to be a hair. There's some red, black, yellow blood right there. This is all bloody stuff. That's right out the outside edge. It's crazy, huh? Look at that. Look at that. That's, I'm sure that's our vein. But anyway, this, I would absolutely say this is not from a tree. This is Caesars Perch. All right, these are sweat glands. Here's one here, there's one over here, and there's going to be hairs right in the same area. And these are the sweat glands right up here, right at the top. Let me see if I got a better shot at that. All right, here they are up here. They're showing a very short one, but they can go very long. And then you have this down here, which is, you know, the blood vessel. And we saw another shot here. I think I showed you one. This guy, this thing here. Now don't forget, you got your sweat gland, you got your hair, and you got that thing going down at the bottom. There it is right there, sweat gland, the hair, and the main blood vessel right underneath it. There it is right there. That's it. You see it? That is exactly what we just saw in that other picture, which is this picture right here. He's got the hair, he's got the sweat gland, and he's got the tube running through. All right, does that make sense to you? There it is right there. So, as far as I'm concerned, I mean, we know there's hairs, we know there's sweat glands, we know there's, as far as I'm concerned, there's no way you can convince me that something is not biological anymore. There's a lot of things that have transitioned from biology into glass or whatever. Yes, absolutely, no question about it. But in a natural form of things, everything came from biology. And the sunlight is the driver of biology. There's a lot to consider here. This is not just spectacular change in geology and all that stuff, which it is, yes, I have no question about that. But it leads to thinking about the ancient texts and what they did say about the Earth and where it came from and how it developed and how all the planets came about. All that stuff was written about. It's always been considered crazy. But after you see this stuff, there is nothing crazy anymore. This is nothing crazy anymore. All right, so I'm just going to keep laying this stuff out. All right, thank you. Have a sterling day.